Hello, Mr. Betts here. I want to talk about using antiderivatives to evaluate definite integrals and talk about the notation specifically that we're going to use for that. And when we're doing this, we have two options. So I just want to refresh you real quick that in order to do this, we're going to take an antiderivative. So the antiderivative of this I'm going to call big F of x. And that would be x cubed plus 4x because we take the derivative of x cubed plus 4x to get 3x squared plus 4. And remember, there's a plus c here, but the fundamental theorem of calculus says it can be any antiderivative, so we're choosing c equals 0. And then we're going to evaluate this big F at 4, and we're going to evaluate the big F at 1. So we evaluate at the upper limit and then subtract the evaluation of that at the lower limit. And then we plug that in and we go from there. This notation is kind of clunky. We have to do a little bit of side work here. And so we're going to come up with a couple options. I'm going to show you a couple options for some work that's a little bit more succinct and efficient. So the first is using an evaluation bar. You've seen me use this in a previous video. So essentially what we're going to do is we're going to take the antiderivative, just like we did in the example I just showed you. So it's going to be x cubed plus 4x. Just a notational thing here. We really should put parentheses around this because we're evaluating that entire expression. And then we're going to use an evaluation bar. And this is the new notation now with our antiderivatives, or our definite integral, that we're evaluating at 2 points. So we put the lower limit at the bottom of the evaluation bar and the upper limit at the top. Once we have that, we've shown what the antiderivative is, we're showing where we're evaluating that, then we plug in the values. So we're going to plug in 4. We're going to plug in 1. And we're going to subtract them. And I'm not going to go through the arithmetic of doing that, but that's essentially what we're going to do, and then we simplify it. The other option is using square brackets. So notice here that I grouped the antiderivative using parentheses, and then I used an evaluation bar. Well, using square brackets as a grouping tool, like this, we can apply those limits directly to the right square bracket and treat it as an evaluation bar. So this is an accepted notation that you might see in textbooks that you might choose to use. It's an especially good one when you have multiple terms, so we should group those terms together anyway, so we can get that grouping and the evaluation bar knocked out in one symbol. So then we, again, like the other one, we evaluate it now. So 4 cubed plus 4 times 4. So this is no different than what we did the other way. So either notation is acceptable. You will see me use both. I will tend to use the square brackets when there are more than one term in the integrand. And then I will usually use the evaluation bar when there is only one term. Sometimes I might use them interchangeably and not necessarily always for one of those cases or the other.